I am Geetha, Assistant Professor, Department of Mathematics, SNS College of Engineering. Now I am going to discuss about case study on differential equations. Problem statement. In an LCR circuit, the charge Q on a plate of condenser is given by L into d square Q by dt square plus R into dQ by dt plus Q by C, which is equal to E sin pt. The circuit is turned to resonance so that P square equal to 1 by L into C. If initially the current I and the charge Q are 0. Show that for the small values of R by L, the current in the electric circuit is given by Et by 2L into sin pt. Here LCR circuit is nothing but electric circuit. L represent inductor, C is capacitor and R is nothing but resistor. The charge Q on a plate of condenser is given by the differential equation L into d square Q by dt square plus R into dQ by dt plus Q by C, which is equal to E sin pt. Now the circuit is turned to resonance. So P square value is given here 1 by L into C, and initially the current I and the charge Q are 0. Now we are going to show that for the small values of R by L, the current in the circuit is given by Et by 2L into sin pt. For finding the current in this circuit, we are going to use differential equation concept. Before solving this problem, we should know the prerequisite is differential equations, types of differential equations, order and degree of differential equations, finding solutions of differential equation. Differential equation. A differential equation is an equation involving derivatives of unknown function and possibly the function itself as well as the independent variable. Here L into d square Q by dt square plus R into dQ by dt plus Q by C is equal to E sin pt. Here this equation contains derivatives. So this is nothing but differential equation. Next, types of differential equations. We have two types of differential equation. One is ordinary differential equation, another one is partial differential equation. Ordinary differential equation means its derivative with respect to single independent variable. In this example, L into d square Q by dt square plus R into dQ by dt plus Q by C equal to E sin pt. Here Q is with respect to t only. So this is example for ordinary differential equation. Next, partial differential equation means its derivatives with respect to two or more independent variable. Here dou z by dou x plus dou z by dou y, which is equal to sin pt. In this equation, z with respect to x and y. So this is coming under partial differential equation. Ordinary differential equation, we denote the symbol d. In partial differential equation, we denote the symbol dou. Order and degree of differential equation. Order of a differential equation is the order of the highest derivative that appears in the equation. Highest derivative's power is known as degree. Consider this differential equation d square y by dx square plus p into dy by dx plus q into y, which is equal to r. Here highest derivative is d square y by dx square, so order is 2. Its power is 1, therefore the degree is 1 here. Next, solution to the second order ODE. General form of the linear differential equation of second order is d square y by dx square plus p into dy by dx plus q into y, which is equal to r, where p and q are constants and r is a function of x or constant. Differential operators. The symbol d stands for the operation of differential and 1 by d stands for the operation of integration. The above equation can be written as d square y plus p into dy plus q into y, which is equal to r. Or we can write d square plus p into d plus q into y, which is equal to r. Next, its complete solution y is equal to complementary function plus particular integral. Next, formula for finding complementary function. For this, we have to first make the auxiliary equation. By using auxiliary equation m square plus pm plus q is equal to 0, we get the two roots. Roots are real and different. That means m1 not equal to m2. Its complementary function is a into e power m1x plus b into e to the power of m2x. In case roots are real and equal, that means m1 equal to m2, which is equal to m, means its complementary function is ax plus b into e to the power of mx. Roots are imaginary, that means alpha plus or minus I beta, means its complementary function is e to the power of alpha x into a cos beta x plus b sin beta x. Next, solution to the problem. Given differential equation is L into d square q by dt square plus r into dq by dt plus q by c, which is equal to e sin pt. Here we are supposed to find the current I value. For that, for solving this differential equation, we get the q value. Differentiating q with respect to t means we get the current I value. So, the above equation can be written as L into d square plus r into d plus 1 by c into q, which is equal to e sin pt. Solving this equation, q is nothing but complementary function plus particular integral. First of all, we have to find the complementary function. For that, we have to consider the auxiliary equation L into m square plus r into m plus 1 by c, which is equal to 0. For solving this equation, we have to use b square minus b plus or minus square root of b square minus 4ac divided by 2a formula. Here a is nothing but L and b is nothing but r, c is nothing but 1 by c. Using this, the roots are given by m is equal to minus r plus or minus square root of r square minus 4l by c whole divided by 2l, which is equal to, separating this, we get minus r by 2l plus or minus square root of r square divided by 4l square minus 1 by l into c. Since r by l is small, then the term r square by l square may be omitted. For example, r by l is 0.1, means r square by l square value is equal to 0.01. So, it may be omitted. M is equal to minus r by 2l plus or minus square root of minus 1 by l into c. Minus 1 is nothing but I square, taking outside we get, which value is equal to minus r by 2l plus or minus I into square root of 1 by l into c. Here p square value is equal to 1 by lc and also greater than 0. So, p is nothing but square root of 1 by lc. Using this, we get which value is equal to minus r by 2l plus or minus I beta. Here the roots are imaginary, that means alpha plus or minus I beta. So, the complementary function is equal to e power alpha x into a cos beta x plus b sin beta x. Using this, we get complementary function is equal to e to the power of minus r by 2l into t, c1 into cos pt plus c2 into sin pt. Here e power minus x is nothing but 1 minus x plus x square, etc. So, instead of x, here we are having rt by 2l. So, which value is equal to 1 minus rt by 2l plus r square t square by 4 into l square, etc. into c1 cos pt plus c2 into sin pt. Omitting the higher power, the above will become 1 minus rt by 2l into c1 cos pt plus c2 into sin pt. Next, we are going to find the particular integral, that is equal to 1 by f of d into right hand side function. So which is equal to 1 by L into D square plus R into D plus 1 by C into E sin PT. Here the function is trigonometric function, so instead of t square we are going to replace minus p square. So replacing this value we get the above will become E into 1 by L into minus p square plus R into D plus 1 by C into sin pt. Here p square is equal to 1 by L into C. Substituting this value here, the above will become E by R into D sin pt. Here in denominator we have D. So in denominator we have D means this is nothing but integration. So which value is equal to E by R into integration of sin pt into dt. Integration of sin we get minus cos divided by t's coefficient p. So which value is equal to E by Rp into cos pt. Next, the complete solution is given by Q is equal to complementary function plus particular integral. Complementary function is 1 minus RT by 2L into C1 cos PT plus C2 into sin PT minus E by Rp into cos PT. Keep this as equation 1. Now we are supposed to find I. I is nothing but rate of change of charge with respect to time, that is equal to, here we are going to use U and V formula. So keep U is fixed, differentiating V we get minus C1 into sin PT plus C2 into cos PT into P. Then keep V is fixed and differentiating this we get minus R by 2L into C1 cos PT plus C2 into sin PT plus differentiating cos we get sin PT divided by sin pt into p. So this value become plus E by R into sin pt. So I value is equal to 1 minus RT by 2L into minus C1 into sin pt plus C2 into cos pt into p minus R by 2L into C1 cos pt plus C2 into sin pt plus E by R into sin pt. Keep this as equation 2. Initially Q and I values are 0 when t is equal to 0. Substituting these values in equation 1, we get C1 is equal to E by Rp, and substituting Q equal to 0 and I equal to 0 when t equal to 0 means equation 2 will become C2 value is equal to E by 2L into P square. Next, substituting C1 and C2 values in 2, we get I is equal to 1 minus RT by 2L into minus E by Rp into sin pt plus E by 2L P square into cos pt into P minus R by 2L into E by Rp into cos pt plus E by 2L P square into sin pt plus E by R into sin pt. Here R by L is very small. Omitting this we get the above will become I is equal to E by Et by 2L into sin pt. This is our required current. Next, applications of differential equation. Differential equations are used to model the behavior of a complex system. Exponential growth of population, exponential decay of radioactive material, and also used in Newton's law of cooling. Thank you.